Okay, folks, let's get to it. All right, this is 4.2, solving systems by graphing. We've seen most of this stuff already, but let's really kind of dive down and make sure we know what we're doing here. So when we talk about systems of equations in general, we've got three types of solutions, right? We have one solution, no solution, and infinite solutions, right? I will show you what they look like, and that way it will hopefully make more sense as to why we have these different types of solutions here. So I'm just going to graph these two right here. I've got plus 5 up here. I'm going to go down 3, 1, 2, 3, and write 5. Okay. And as I graph them, or as I put the points on there, I'm going to graph the line because I think it is easier to see rather than one at a time, right? Because I don't want a lot of dots on here that represent two different lines because then it's confusing to me if I have to do that. So I start at -2, and then I'm going to go up 3, write 1. 1, 2, 3, write 1. 1, 2, 3, write 1. Okay. We got that right here. Let's see how many times did the lines cross. Well, they cross once. One solution. Okay, so when lines cross once, they have one solution. At what point do they cross? 2, 4. I think it's actually slightly different than 2, 4. Let me double check. I was looking at that in class and I was like, I think it's actually very slightly different than that. But let's just do a real quick Desmos check here. See, the problem is that when you're graphing with pencil rather than like a graphing program, you can kind of get off, not exactly correct, but you can get very close to it and not be able to really tell, especially if you're not really super practiced at it. Let's see, -3/5x plus 5 and 3x minus 2. Yeah, right? So technically it's 1.9 to 3.8, which is really, really close to that 2, 4. So we'll just leave it at 2, 4 right now. What do the equations have in common and how are they different? Well, we can see that they each have y and x, right, as their variables. So we'll say in common, if I could actually spell correctly, that'd be great. In common, different. Yeah, let's do no, I don't want to set it up like that. Okay, well, for the same thing they have the same x and y's. Same x's and y's. All right, but they have different slopes. Okay. Right? I look at that -3/5 and I look at that 3, so different slopes right there. And then they also have different y-intercepts. Okay? So we look at that plus 5 and that -2. So we can see that basically everything about these two equations is different. Now, the problem is that when you look at that, you can see oh, well, if for problem types that have one solution, they're always going to have different slopes and different y-intercepts. But that is not true, right? The only thing that really matters is if they have different slopes, they automatically cross once. They could have different y-intercepts or the same y-intercept, and they'd only cross once. Let's real quick explore what that looks like here. Okay. So yeah, I could change this to have I could change this to have the same y-intercept but different slopes, and you can see that they're still going to cross just once, right? So the y-intercepts, let me start that over. The important thing is if they have different slopes, they automatically cross once, right? That's kind of what I'm getting at right here. Okay. All right, now when we take a look at this no solution, we can see that we have the same number here, different numbers here. Okay, so +2, we start at +2, and then we're going to go up 2 and write 1, up 2, write 1, and then I'll reverse the pattern here like so. And again, I want to graph the line before I move on to the second one. Okay, and then I start at -3, and I go up 2, write 1, up 2, write 1, up 2, write 1, up 2, write 1. And reverse it as well to get an extra point on there, and then I can see that these are parallel lines. Okay, So how many times do they cross? Well, they don't cross at all. They do not. How many times do they cross? Never. So when they never cross, no solution. Okay. At what point do they cross? They do not cross. And what do they have in common, and how are they different? Well, they have the same x's and y's. That's kind of like the base. All these equations are going to have the same variables. Okay. Actually, I like the same x's and y's. That's kind of a Mickey Mouse way to say it. Same variables. Okay. What do they have the same? They have the same slope as well, but they have different y-intercepts, right? And that's the specific characteristics of systems of equations that have no solutions, is they have the same slope and different y-intercepts, right? Okay. Now this one's a little bit tricky right here. I'm trying to trick you, because if I didn't try to trick you, it'd be really easy to figure out. But the idea here is that we have this in y equals mx plus b, and we have this is actually technically in standard form. So what we'll do is we'll put it in slope-intercept form by taking that 1/2 x to the other side, and then it becomes y equals 1/2 x plus 1, which is the same equation, right? So this line that I'm doing right now is the first equation, this one, and then this one right here is the second one. So I'm gonna do like this so we can see that there are two lines right on top of each other, right? It's the exact same line, okay? So that's this one right here, okay? How many times do they cross? Well, they cross infinitely, right? Okay, every point on one line matches to another point on the other line, okay? They cross infinitely, so, oh, look at that, infinite solutions. At what point do they cross? At every point, okay? And then what do the equations have in common and how are they different? Well, if you didn't put them in the same format, then you wouldn't realize that one has a negative, they both have positive slopes, right? If you just kind of like took this and started graphing, you might get a line that looks like that, and then you would be making the wrong assumptions here, right? So, same variables, obviously, right? Okay, but they also have the same slope, the same y-intercept, which means that it's just the same line / equation. Okay, so 3 types of problems, right? Crossing once, not crossing at all, crossing infinitely. Okay, all right. Now we've got some specific problems here. Find the solution to this system of equations. You might say, oh, it's got one solution because it crosses once. Yeah, technically true, but when I say find the solution, I actually want you to tell me where they cross. So this point right here is -4, 2. Just like that. Okay. Let's see. I'm going to graph this, and then I'm going to do the exact same thing. Start at +4. I go down 5, and then over 2. And then I will draw my line. All right, finish drawing your line before you move on to the second one. Okay, use a ruler, please. Starting at -2, going up 1 and right 2, up 1, right 2. Let's reverse it a bit. Okay, so that means solution's right there at 2, -1. Okay. Okay. What's the missing equation? Well, this -2.5x plus 2. Clearly, this is the negative one right here, right? So that one's already taken care of. So I got to figure out what this equation is, the positive equation, right? So I know it's increasing, so I know that the slope is going to be positive, and I know that my y-intercept is going to be here at that -5. So I'm actually going to put that up there, right there, right? That's my y-intercept. This one is at +2, so that's kind of like a guide to another one. Like this one is already done. And now I got to figure out a point, 2 points to kind of like get my slope. I got it right here. It's going to go up 4. It's going to go right 3. So that's my slope right there is at 4/3. So y equals 4/3 x minus 5. There you go. TQ, test question. Oh, this one's also a TQ. This one's also a test question. Okay. Find the solution here. Well, we can already know, we should know that this is not going to have any solution, right? Start at 2, we go up 1 and right 3, reverse it to get another point. Okay, starting -3, going up 1, right 2, up 1, right 2, get a few other points on there. Oop, hold on. Did I screw this up? I did. Yeah. Just like so. Oh, come on, Wishart. Why did I screw this up? Oh, I did up 1, right 2. I should be going up 1, right 3. Well, that's a good thing. I used a pencil on this. So -3, and then up 1, right 3, and then down 1, left 3. There we go. That's much better. Okay, those look parallel. Well, they look more parallel at least. So solution, none. Cool. Spiral review. Reflect this, DEF, over the y-axis to form D prime, E prime, F prime. So D is 2 away here. This is the y-axis, right? So D prime is going to be 2 away. E prime is going to be 5 away. So right there, E prime and F prime is 4 away. So right there. Boom, there you go. Enjoy.